Hey everyone, welcome to your first PARCC review video. For this video, I'm going to go over the first couple of questions so that you can get started on this packet and you don't have to save it all for spring break. So it says several points are plotted on the graph, right? So we have a point here, 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 right? It says which of the plotted points on the graph represent the zeros of the function? Select all that apply. Okay, so honestly, these points don't really matter. We first are going to need to solve for our zeros. We have one of them factors being x minus 6. So I know that if I do x minus 6 equals 0, one of them is going to be x equals 6. And so one of the zeros will be 6 comma 0. Now, if I'm looking at this one right here, I need to factor that. So I'm going to go ahead and factor it so that I can find my zeros here. And I need to think about what two numbers equal negative 8 when multiplied, but add to give me positive 2. And that would be positive 4 and negative 2. 4 minus 2 is 2. Positive 2 and 4 times a negative 2 is negative 8. So x plus 4 times x minus 2. And x minus 6 equals 0. And I need to set each of those equal to 0. So if I set each of these factors to 0, then again we got x equals 6 for this one. We'll get x plus 4 equals 0, so x equals negative 4. That's one of them. And then x minus 2 equals 0 gives us x equals 2. So these are my other two zeros. So we have negative 4 comma 0 and 2 comma 0. So those are the points that would be on the graph. Now, you should recognize that zeros can only be on the x-axis, so you could also eliminate easily that C, F, and G are not even possible because they are not on the x-axis and therefore will not be zeros. All right, let's look at number 2. So number 2 is about rational numbers. So it says A is a non-zero rational number, so nice even fraction or whole number, and B is an irrational number, so one of those numbers with with extended decimals that are not repeating. It says which expression could represent a rational number? Well, negative B would just be a negative irrational number. A plus B, if we add a rational and an irrational, we will still get an irrational number, right? For example, if I were to add 2 plus pi, it's still going to have those extended decimals there. If I multiply a rational and irrational number, it will still be irrational unless A is 0 and it says non-zero. And so D is our best answer because, as an example, if we had the square root of 2 times the square root of 2, we would just get 2, which is in fact a rational number. Part B says consider a quadratic equation with integer coefficients, so coefficients that are whole numbers, and two distinct zeros. If one zero is irrational, which statement is true about the other zero? So if there's two distinct zeros and one zero is irrational, but they have integer coefficients, meaning it's normal like 3x squared plus 2x plus 6, for example, right? That means that when we factor, we are somehow ending up with an irrational number there. And so that means in order for this to be true, the other zero also has to be irrational. So it's similar to the question up above that asks us this because it's showing that if one zero is irrational, in order for them to make a rational number, it has to be an irrational number times an irrational number. That's the only way that we can make a rational number out of that. And so if we know that we have integer coefficients and two distinct zeros, then the only possible way for that to happen is for the other zero to also be irrational. I'm going to go ahead and do number 3 too, just because those two are pretty quick. It says which graph best represents the solution to this system of inequalities. And so notice they're both less than or equal to, which means they both should have solid lines. And what I want to go ahead and do is think about how I can rewrite this equation to be y equals. So I'm going to subtract x from both sides in this first one, so I'll get y is less than or equal to negative x plus 6. That means that I have a y-intercept of 6 and a negative slope, a negative 1 over 1 slope. That helps me to go ahead and eliminate a and b. It can't be those because both of those lines go through the origin, and this one would not be going through the origin, right? It would have a y-intercept of 6. It also tells me that I have a negative slope and both of these have positive slopes, C and D both have negative slopes, so it has to be one of those. Okay, so then looking at the one that has a y-intercept of 6, if we look at this line right here, it's going down 2 over 2, down 2 over 2, so that is a slope of -1. So this line seems to work out pretty well. Let's look at this one. This one is actually going down. It appears at the same rate, so this is also a slope of -1, and we would shade then underneath that value. Okay, so that one seems to work out okay. Let's look at the other one then. So then the other one would be 2y is less than or equal to -x plus 8, but then we need to divide by 2. So we would get y is less than or equal to -1/2 x plus 4. The y-intercept here is 4, and so that would be this line here. Here the y-intercept is 8, but we know that from this equation our y-intercept is 4, so our best answer has to be D. That's the only one it can be. In this case, you didn't really even need to worry about shading. You really just needed to make sure that your lines were correct and that those y-intercepts were correct, because these are two different ones. And remember too, you can always test a point, right? Both of these would have our 0 zeros be true, and 0 plus 0 is less than or equal to 6, and 0 plus 2 times 0 is also less than or equal to 8. So the side that we shaded on seems accurate. This one is more focused on which line should I be looking at, right? Which one represents this line the best? And that key point there is that you need to divide by 2, which makes our y-intercept 4 instead of 8. All right, so that's questions 1 through 3, and I will go over the next few in a separate video tomorrow.